Alright, greetings. Welcome to video 3.5, looking at classifying matter. And we're going to focus on the pure substances on this particular video. So, main objective, compare and contrast what elements and compounds are. Before we begin, make sure you turn off your cell phones and social media. I encourage you guys to pause and rewind frequently, and to take some extra notes in the margins should you have any questions. So, to start, we're going to look at classifying matter of pure substances and mixtures. So, let me actually skip ahead for 1 second and show you this little graph here. We're real quickly going to define what a mixture is and what a pure substance is, but this video is going to focus on this half of the chart. So, to start off, pure substances. Pure substances are matter that have a definite composition. You'll recall we've already defined that back in the first chapter, also known as a chemical. So if you have a chemical or a pure substance, basically that's matter with a definite composition. So for example, do you have helium gas, or do you have the diatomic hydrogen gas, or do you have iron, or carbon dioxide, or sodium chloride? You can have pure forms of those different chemicals. Those are called pure substances. Mixtures are a combination of two or more of those pure substances. So if I had all these gases in a balloon, that would now be a mixture of those substances. So a mixture is a combination of two or more substances. And you'll have to go ahead in your notes a little bit to the next page and put that definition down. Alright, so looking at this chart here, before we kind of go on and take a look at everything, you can see that matter basically comes in two different forms. It either comes in a mixture or it comes in a pure substance. And the way that pure substances are made into mixtures is you literally just mix them together physically. Like you can grind some things up and mix them together. You can dissolve some salt in water. And basically that's called a physical change. And remember, physical changes, you don't change what the substance is, you just change something about it. So if I take, for example, sodium chloride, which is a solid, and if I put it into water, which is a liquid, the sodium chloride dissolves into water, and we'll talk about this later this year. That's called the aqueous state of matter because it dissolved. This basically means dissolved in water. Okay, it's still sodium chloride, it's just now been dissolved into a different state. So you keep the properties. In a physical change, remember, you keep what the substance is, you just change some of the properties about it. So let's start going through here, and we're going to focus on this half of the chart on this video. The other video will focus on the other half. So the first type of pure substance you can have is called an element. And elements are pure substances that you cannot separate into anything more simple by any kind of physical or chemical means. So basically, once you have hydrogen gas, or you have helium, or you have iron, or you have aluminum, etc., once you have those things, that's really as simple as they're going to get. Okay, so those are the elements. 92 of them occur naturally on Earth. The other ones on the periodic table we have to synthesize, and they're man-made. Each element has its own unique chemical symbol, and a chemical symbol is either 1 letter, 2 letters, or possibly 3 letters, and the first letter is always capitalized. So we have hydrogen, just the atom, we have helium, which is He, we have iron, which is Fe, we have aluminum, which is Al, and the second letter or third letter, if possible, they are lowercase. Here's a quick example of a 3-letter one. This is one of the man-made elements. It's un octium, so it's UUO. Capital and then lowercase. And a couple elements like iron and sodium, their chemical symbols are based off of their Latin name. And that's kind of why we have some diversity in the chemical symbols for some of the things. So iron is not I, that's iodine. Iron is Fe. The periodic table is kind of our organizational tool for the elements. Organize the elements into periods and groups. Periods are the rows on the periodic table, and groups are the up and down vertical columns. Elements that are in the same group, they have similar properties. That's kind of a nice way that they're organized by. If a substance is found in the periodic table, it's an element. A little bit later in this chapter, we're going to be asking you to classify things as elements, compounds, and mixtures. And if you don't know what it is, look on the periodic table, and if you see it, it is an element. The other type of pure substance are your compounds. This is when you have two elements put together. So for example, H2O has the elements of hydrogen and oxygen. That's a compound. If I gave you just H2, that's considered an element because it's only made of hydrogen, so that's not a compound. Sodium chloride, carbon dioxide, which we breathe out. Okay, Cars breathe out carbon monoxide. They don't breathe it, they exhaust it. But these are compounds because they are made of two elements bonded together now. And compounds can be separated into their elements. They can separate into hydrogen and oxygen. You can separate this into sodium and chlorine, carbon and oxygen, carbon and oxygen. But the only way you can separate them is by a chemical change, some kind of chemical reaction. Compounds, they do have properties that are different from their component elements. So, for example, sodium is silver and shiny. So I'll do it separate for a second. Sodium comes as a sodium atom like this. Chlorine comes as a pair. This is a yellow gas. Sodium is a silver shiny metal that's really soft. And when you put them together, sodium chloride or table salt, it's white and it's crystals. It's a solid. So whatever your element properties are, the compound they make, their properties will be different than the elements that make it up. So I would like you to write a little description here. Explain how, when you look at this picture here, explain how the compound properties are different from their element properties. Go. Okay, so kind of like I did in the previous page, you should basically say potassium iodide, the compound potassium iodide, is white and it's crystalline, it's a solid, which is different from the silver shiny metal that is potassium metal. And the iodine is kind of a solid. It's purple. It's got a purple haze up here. It sublimes very easily into a gas. And basically there's different properties. The elements have different properties. And when those two elements come together to make the compound potassium iodide, the properties do change for the compound. They are not going to be the same. So just to kind of recap here, look at the chart here, we just focus on matter that is pure. And the two different types of pure substances you can have are pure elements that come off the periodic table. Or if you have two elements bonded together, two or more elements bonded together, you have a compound. Those are your two different types of pure compounds you can have. And they can change into one another if you go through a chemical reaction. Elements can chemically react to make a compound, and the compound can chemically split back apart into its elements through a chemical change. In the next video, we'll look at how you take these things together and mix them together, and now we'll make mixtures. All right, good job.